So this is the Raspberry Pi that is used for all the central processing for ML purpose, and it does all the processing required for fertilizer and crop production. Then we have sensor nodes, as you can see, 1, 2, 3, 4, 4 sensor nodes along with the probes into the soil, as you can see. Then these nodes convey the data to the Raspberry Pi through Firebase. We store the data of the nodes in the Firebase, through which in real time it conveys the data to the memory, to the processing of the Raspberry Pi. Now I will show you by running this command and running the model in real time. So let's see how it runs. So first we will run the code, the Python code. Then it's asking for year. We will give a year 2026, a DOI, date of the year, the day, that we will give 1210. Then it will fetch the real-time value of RH2M. As you can see, this is the relative humidity value from the gateway node, node 1, node 2, and it does an average of all the nodes. This is the node 1, node 2, node 3, node 4 gateway, and it does an average of it that we get through the Firebase using real-time connection with it. Then we will input the value of nitrogen, N, then phosphorus, then potassium, then pH. Then it asks for available soil type. We have 5 available soil type: black, clay, loamy, sandy, sandy loam. So we can add one. We add loamy, and you can see that we have done the prediction. We take input year, DOI, RH2M that we got using average of all the nodes in real time. Then we did the predicted temperature. We first predicted the temperature using the values of year, DOI and RH2M. Then using the predicted temperature, we predicted the rainfall and the seasonal rainfall. That's a 120 period, day of rainfall period. Like we take a period of 120 days and we just get the rainfall over that, and we take an average so that we can get the daily rainfall, right? Then using all this, we predict the crop and the fertilizer required as per the NPK value. So you can see clearly over here.